Hi, everybody. There were some questions about how to do some of the larger state minimization issue questions. These are the ones that involve implication tables. And when you're doing the implication table, what you want to do is you want to try and see first if you can do row minimization, and then you want to try and do something involving the implication table. And in this case, we're going to do what we call a Mealy machine, and that's because the output is a function not only of the present state, but it's also a function of the input. So for the next state, we'll try x equals 0 and x equal 1, and for the output, we'll show what happens when x is equal to 0 and x is equal to 1, and we're moving from one state to the next. And so for our present states, let's list a few states. A, B, C, D, E, F, G, and H. So that'll give us a few states to work with. And then for our next states, let's make sure that row minimization will do us no good, at least on first inspection. And so what we'll do is we'll come up with a series of let's see, EF. How about DA, BF, DH? So let's see. We'll do CF, BH. Let's do this one. How about EF? And then we'll do DA. Then we'll do BF. And let's try DH. And then maybe what we'll do is HG. I'm not going to write out the state diagram because it's a little complicated. And then for outputs when x is equal to 1, we'll just make it all 0. And then for outputs when x is equal to 0, well, we'll make it a 1 for H. And let's make it a 1 for F. And then the rest can all be 0. So then the question becomes, all right, so how do I formulate the implication chart on something like this? And first thing you do is you look at it and you go, well, can I compare AE with anything? And the answer is no. How about CF? Nothing. BH? Nothing. EF? Nothing. DA? Nothing. BF? Nothing. Really, we have no way to do any kind of row reduction here. So now you have to deal with the question of how you're going to set up your implication table. Now what I like to do is I like to start from the second element and work my way down to the last element. And so what we'll do is we'll work that into our expression. B, C, D, E, F, G, and H. B, C, D, E, F, G, and H. And then across the bottom, we'll start with the first element, and we'll work to the second to the last element. So it'll be A, B, C, D, E, F, and G. A, B, C, D, E, F, and G. And let's work our way through this problem here. So what we'll do is we'll write out the implication table as a lower triangular table. And then when we look at the first pass through the system, we want to try and eliminate anything which has a trivially different output. So comparing A against B, we can see that's different output, so we can put in an X. Similarly, C, D, and E all have different outputs from A, so that all has an X. G also has a different output. When we compare B against F, it has a different output. When we compare C against F, it has a different output. When we compare D against F, it has a different output. When we compare E against F, it has a different output. When we compare F against G, it has a different output. And when we compare G against H, well, it has a different output. So then you look at it that way and you say, oh, all right, that makes sense. But what have we missed? Well, it looks to me like H is different from G. We got that. But H is also different from E, D, C, and B. You can see that over in here. H is different from G, E, D, C, and B. So if you go back to H and you see C, D, E, and B, that's consistent with what H is different from. So if you're looking for B against, for example, H, you can see that there's a difference. C against H, there must be a difference. And so we don't put in a difference, for example, between A and H, right? Why is that? Well, because the outputs are trivially not different. And so what that gives us is the ability now to kind of eliminate a whole sequence of different outputs from our implication chart. And then from this, if you want to make your relationships clear, you want to go from A to F. So if you go from A to F, we see A, B, E, F, right? And so we put A, B, E, F right in the squares. And when you want to go from A to H, well, we see over in here A and H, so it's A, H, E, G. But AH is already part of the transition in going from A to H, so we don't put that in again. Instead, we leave in only EG. Well, that's a very important thing, right? And similarly, when we look at something like AF over in here, if we check it out, we can see AF goes to AF, but this is actually saying something else. This is saying AB and EF have to be equal in order for AF to be equal. And if you look at A and B, it's already got an X in it. So in your first pass, you can right away eliminate that one. Moreover, if we look at F, B and C, right, that's over here, BC, well, we can check from B to C, and we see CB, so we leave that alone because we're already going CB. And then how about FH, right? We know CB is equal to BC. That's, you know, it's an equivalent change in state. So how about this FH? We can put that in there. And similarly, when we go from B to D, we see CE and then FF. Well, we know F is equal to F, so we just leave the CE in there. And when we go from B to E, here's B, E, we see C, D, and AF. Right, so CD, AF. And when we go from B to G, there's B, here's G, we see CD and FH. So we can put that in, CD, FH. Moving along, going from C to D, we see BE, FH. I realize now that doesn't quite look like an E, so let's make it clear. That's an E. And then when you want to go to from C to E, that's C, that's E, then you go over in here and you look at C and E and you see BD, AH. So you put that in there, BD, AH. Now going from C to G, here's C, there's G, it's BD, FH. BD, sorry, C to G, BD, HH. Well, H is equal to H. That's all right. So let's just leave in BD. So there's BD. So half the battle is filling in this implication table. Going from D to E. Here's D. There's E. I see DE, so that's the same. How about AF? We put that in there. Going from D to G now, I can look at D, and I can look at G, and I see BD, FH. Let's do that again. We're going to go from D to G. Here's D. Here's G. It's DE, FH. DE, FH. And that looks right to me. Now we want to go from E to G. So here's E, there's G. That looks like DD. Well, DD we leave alone. We don't put that in there because D equals D. How about AH? We can put that in there. AH. Now, how about this little one here, FH? Well, let's see now. F to H, that's BHFG. So we can put that in. BHFG. And now, if I look around over in here, I can see, wait, here's F and G. That's got an X in it. So if F and G's got an X in it, then this must have an X in it. So in my first pass, I've eliminated most of my next states. And so now, if I go in over here and I look at FH, here's F, there's H. Wait a minute, that goes too. And then I go over in here and I look at CE, and I see CE, that's okay. I look at CD, I see CD, that's all right. I see AF, here's AF. Oh, wait, that's got an X in it, so this now has an X. And now I look around for any BEs, and there's a BE over in here. And so that means CD must also be removed. So if I see a CD, I say, aha, and now that means BG must be removed. So if I see any BGs in here, they go. So far not. So now go back to the beginning. CE, that's okay. H, yeah, that looks all right. EG, let's look at EG. E to G, that's all right. Let's look at BD. So now I have B, and here's D, and that's all right. Now I look at DE. So here's D, and there's E, that's fine. And I look at FH, here's F, and there's H. Hey, wait a minute, that's no good. So now I got to go back to anything containing GD. And I don't see anything containing GD. So we're all right so far. Now how about this AH? So I go AH, and that's okay. So now, at the end of the day, it looks like A is equal to H. E must be equal to G. And C must be equal to E. And what about this AF over here? AF. Oh no, that's not good. Got to take that out. That takes out ED. ED doesn't impact any of the other squares. So now A equals H. Where can we write the next thing? Let's see. C must equal E, right? Because C is equal to E. But C is also equal to G. So that's a nice simplification right there. And now if I look at B and I look at D, I see, aha, those are also equal. So B equals D. And that's how you do that. Thank you.